So in this video, we're going to look at differentiation with vectors. And in particular, we're going to look at the relationship between displacement, velocity, and acceleration. So we saw in our previous mechanics lessons that if you want to work out the velocity given displacement, well, we can differentiate the displacement. So we work out ds by dt, and this will give us the velocity, because we know velocity is the change in displacement over time. And to work out acceleration, well, this would be the change in velocity over time, or the second derivative of displacement. So these are the ideas that we've already met in previous mechanics lessons. But in this video, we're going to be applying these ideas when motion is modelled using vectors. So if we look at example 1, a particle moves on a horizontal plane where r, which is the position vector, so a measure of displacement, is given as this expression for I and this expression for j. We've been asked to work out an expression for the velocity of a particle at time t. So we know that velocity is the change in displacement, which is given by this position vector, so in this case dr by dt. So to work out the velocity from this vector, all we need to do is differentiate the I component and the j component, both with respect to t. So dr by dt then will be the derivative of e to the half t, which we can do using the chain rule. We'll bring this half down, and this will multiply to make 1, so we'll get e to the half t. We differentiate the negative 8t, and this t will go, and we're left with negative 8. And then we differentiate the 5, and this is a constant, so this will go. So differentiating the j component, the derivative of t squared with respect to t is 2t, and the derivative of negative 6t becomes negative 6. So this will be the velocity as a vector of the particle in terms of t. This will be in meters per second. Okay? So to work out the acceleration, well, we know this is dv by dt, and we've just worked out the velocity. So all we need to do now is to differentiate each of these components, this I and this j. We differentiate the e to the half t. Again, using the chain rule, we'll bring this half down. So this will become 1/2 e to the 1/2 t. This negative 8 is now a constant, so this will go. And then for the j component, we differentiate 2t with respect to t. And this t will go, and this constant will go. So this will become over 2. And this will be in meters per second squared. Okay?